In this video, we are going to look at the use of a differential GPS for carrying out a topographic survey, taking data points in a particular location. In most cases, when you are talking about a topographic survey, you often will be talking about a geoinformatic surveyor. You will not be talking about a civil engineer or a builder. But in most cases, the data from these surveyors are submitted to the engineers and builders, for which they require this data to carry out their design. So in some cases, it's actually required for engineers to actually understand how this data is being gathered by the surveyors in order for them to make requests of the surveyors in their data acquisition program. In most cases in schools in the past, what engineers have been taught about surveying centers around how to take levels, forward side, back side, as well as to do traversing in order to create a map. But when you are talking of topographic survey, you are talking about a map area of which the elevation and coordinates have been identified and ascertained with data acquisition. In this video, we are going to look at how a topographic survey can be done by data acquisition using a GNSS receiver and device in order to establish the elevation of different points in that location. There are different ways to actually do a topographic survey, and there are videos online you can always search to see how surveyors do it. A topographic survey can be done through the use of a total station. A topographic survey can be done through the use of a differential GPS. I know in present day world where we have multiple technologies that are widely available, in the world today, the challenges we are facing are more enormous than in the past. However, the tools and software and applications we can use to model problems are more advanced and are simpler to use than in the past. So the problems we have commensurate high-level advanced softwares to combat them. So when you are talking of a topographic survey, you can do a topographic survey. In terms of design, if you are carrying out design for a new project, let's say you are initiating a project, for an engineer, the first thing you need to do is to carry out a desk study. In other words, you have to do a study right at your table, gathering data from existing or past projects. So there are some cases where you may not actually have data. For example, if you want to do a topographic survey for a location and you don't have primary data from somewhere else, with the available softwares and applications and programs, it's very easy for an engineer to do a topographic survey prior to engaging the services of a surveyor to actually do a topographic survey. So at the stage of carrying out a conceptual design, an engineer can actually use Google Earth and other applications. If you do a search online, you'll know the different softwares and applications that you can use to do a topographic survey. So when you generate DEM files, which are digital elevation model files of the locations, let's say you have a location on the map and you say Africa and you want the elevation of the whole Africa, although it's going to be a very large file, but you can actually generate a DEM file that you can use to actually model the topography of Africa. So two ways for you to actually do a topographic survey is, first of all, from your desk, which you can do with the available softwares and area photography that have already been generated online, or you can actually generate. The second method is to use surveying instrument, and this surveying instrument could be a total station or a differential GPS. In this video, we are going to look at the use of a differential GPS for carrying out a topographic survey, taking data points in a particular location. So you'll see in this video, you'll see two boxes in this video. These two boxes, they may look similar, but they are actually different. On these two boxes, one is written, the label on the boxes, one is written GNSS base and the other one is written GNSS rover. So GNSS is actually Global Navigation Satellite System. So this is a system whereby you have above the earth hovering And you have receivers on ground here which can actually pick up signals in terms of coordinates and location of those points where those receivers are. So it actually coordinates with multiple satellites in order to get accurate data. Then another concept with topography is actually the RTK. RTK actually means real-time kinematics. So with real-time kinematics, you can actually in real time correct errors from satellite data and receiver information. So it's actually correcting the data you are obtaining from the satellite, as well as that's for your coordinates and your elevation. So it's actually updating it for you automatically. That's basically what RTK means, the real-time kinematics. So it's a more advanced feature. Rather than going later to do some correction factors and to do some manual calculations, RTK actually does the automation of those correction of satellite position and the actual location on ground. So basically, for you to actually use the differential GPS, basically what you're going to do is you're going to set up the base device. You set up the base GPS in one location. You then calibrate the rover according to the base. So the base would have already picked up data as to the satellite and the elevation at that point. So that base GPS is now going to be calibrated with the rover GPS. So the elevation of that base GPS, the coordinates, is going to be calibrated with the rover. And once that rover has been calibrated, as well as the data receiver device, which is going to be attached to the stand of this rover GPS, that receiver is also going to be calibrated for both of the GPS to work in synchronity. And once that has been done, this data receiver is going to be capturing all this data and be storing it. And at the end of it all, you can actually transfer this data from the receiver to a file. It could be an Excel file or any other file or a CSV file. So we are going to look at how this surveying work was carried out. The rest of this video is going to show you the basic setting up of the devices, the calibration, and the picking up of some points within the community. So if you want further study as to how you can actually do a topographic survey, it's possible for you to do searches online to see the different softwares that you can use to do a topographic survey without going to sites, as well as for you to do a topographic survey. This video I've explained will help you further. So you can see these two boxes. To the left is the GNSS base and to the right is GNSS rover. So the GNSS base is going to be kept in one location, while the GNSS rover is going to be taking around the whole landmass within which we want to carry out the topographic survey. So where we want to carry out our data acquisition. So the first steps is for you to actually set up the GNSS base. So the tripod is being set up, as you can see, solid and firm. And in the process of carrying out this topo survey, there was actually some rainfall. So we're trying as much as possible to protect these devices because they are sensitive equipment and also expensive. So you don't want to have them damaged due to negligence. The kind of terrain you walk in can actually damage your equipment, but those equipment are required, although they are heavy duty, you actually still need to protect them while you carry out your survey. There is a particular rod that I actually use to extend the GPS above the tripod. There is also an antenna for the GPS device. So you fix the battery, you fix the antenna for the GPS device, then you connect it to that rod and place it on top of the tripod. So because of the rain, you actually had to come with waterproof bags in order to protect the GPS devices. So once you are installing it, even if you have to work under poor weather conditions, you can actually protect your device to prevent damage to the device. So that's the base GNSS GPS installed on top of the tripod. You can't really see it now because it has been protected with a waterproof bag to protect it from the rain. But this is what it looks like. So here you see him installing the GNSS rover. So is this particular GPS that is going to be taking around the site, the subject site for which you want to take topographic data for the survey. So this is the GPS device that is going to be taking around the site in order to pick up data in terms of coordinates and elevation. So it also has an antenna and battery as well. It's similar to the GNSS base, however, its function is different. So it's placed on this pole, and on this pole you are also going to have an attachment for a device that collects data. So this device will be collecting data for the coordinates. So depending on the coordinate system being used, so it could be UTM system or any other coordinate system. So depending on what is being used, that device, that receiver and data collector device is going to be calibrated according to the UTM. You need to calibrate this data collector device in order to synchronize the base GPS, the rover GPS, and the data collector itself. So these three different devices need to be connected. So you can see this is a snapshot of what it looks like. So you can see selection of projection, projection coordinates for the location, as well as other data, the name of the community, and other information. So this is the process of calibrating it and placing it on top of the accessory of the pole so that it stands on its own as data is being collected along the location. This device will be updating accordingly. Also, when you are taking points within a community or a location, you can actually be defining different codes. So this device allows you the opportunity to define code for a point. So for example, if you have a location that is a water level position and you're not going to take it as a regular ground point, you can actually define it differently by using a code. For example, if you also want to take the edge of the building, you can actually give it a different code. So this device allows you to do all of that. And once you get the file as a CSV file, the data will show you all of what you have picked up in the process. So this is the data that was gotten from this surveying exercise. You can see the different columns for the coordinates, which is based on that projection system. You can also see the RTK, the different modes of the GPS system, which determines the different corrections or adjustments to readings that were taken on the device. So that's basically how you can actually do a topographic survey. So once these points have been gotten, these coordinates and elevation. So for a topographic survey, these coordinates and elevation will then be imputed into a CAD software. This CAD software will then generate a 3D view of the surface. So it's going to show you undulations of that surface. So if you want to, there are different softwares that can be used, but one of the softwares to use is Civil 3D. With Civil 3D, you can actually input all these points with the projection coordinate system. And with that, you are able, the points will generate in the actual location in the whole world where you have selected as the coordinate system. So it is going to generate it for you automatically. And with this data, you're able to plot different forms with that topographic survey. Even with that topographic survey, if you want to design a road or any civil engineering feature or engineering feature, you can actually use that topographic data to actually commence your design. If it's in terms of preliminary decision making, it's possible for you to actually use those earlier softwares I spoke about, including Google Earth, to generate digital elevation models, DEMs. And with that DEM, you have created a surface. That surface can be used for preliminary understanding of the site's proposed location for a project. So this survey you are doing with instrument is the actual values that you have on ground. So you can do one at your desk and you can do the other actually on site. So if you want to compare both, it's fine. But one gives you a general idea about the terrain and the nature of how the site is, which is very necessary. So if you have that preliminary information before you go ahead and carry out your topographic survey on site, is quite helpful. So you have more information while you're on site. So you see here when we're taking points within the community. So once you get to certain places, there are different distances that you can be taking points. So maybe you are taking points every 5 meters, every 10 meters, or say every 50 meters, depending on the level of detail you require. Also, there are different standards you can check online to know whether you are taking a 2.5-meter distance, 5-meter distance, 10 meters distance, or even 25-meter distance. So for example, if you have a generally flat terrain, it's easier for you to pick up data at much larger distances, let's say 10 meters or more. But in terrains where you have for example, a mountainous terrain, which is a rough and mountainous terrain, you may actually want to take your points as much closely spaced distances. So it depends on the standard that you are following, which needs to be checked properly before you actually commence. So this is here, a point was just taken. So it's simply placing the instrument on the ground and clicking in order to get the point. So at this point, we are taking the elevation for the current tidal level in relation to the shoreline of this community. So you got a certain height with this device. So basically, if you want to do a topographic survey as an engineer, you can do it right at your table using software and maps which have already been generated with satellite images where you create DEM files. To have a confirmation, you can then work with a surveyor on site to carry out actual points and elevation information in the location where you want to work using either a total station or a GPS. So with that terrain information and topography, you can actually carry out the design of roads, bridges, drainages, pipelines, and such pipelines could be those for oil and gas. So it has multiple applications. So basically, this is how you can actually do a topography survey if you are an engineer or a builder. Thank you for watching this video. This is Catchment of Resources, where we create for better living.